Yes, please.
Yes, my paper is titled Predictive Analytics in Pilot Training in Southern Africa. Authors is myself, Sibusiso Mzulwini. I am a postgraduate in informatics student at the Tshwane University of South Africa of Technology in South Africa. The co-author is Dr. Tendani Lavhengwa, who is a senior lecturer and section head of postgraduate studies in TUT in South Africa. In terms of the abstract, the aim of the paper is to enhance aviation safety by identifying and addressing pilot performance weaknesses through data-driven techniques. It focuses on strategic adoption of predictive analytics in pilot training across Southern Africa, particularly South Africa, Namibia, and Botswana. The main objective is to utilize advanced techniques like natural language processing, machine learning, to analyze aviation incident reports and identify patterns of pilot errors and potential risk. Studies results highlights the key insights that pave the way for tailored training programs designed to mitigate these issues. The study achievement includes filling a non-empirical gap by applying the Diffusion of Innovation framework to examine the adoption of predictive analytics alongside recommendation of standardized reporting, specialized training modules, and integration of weather analytics. The outcome demonstrates the transformative potential of predictive analytics in improving pilot training and enhance aviation safety in Southern Africa. In terms of the content that I'll cover is introduction, method used, literature review, the rated information system, conceptual framework, the conceptual framework that has been used, data source to justify the data source and evaluate the data source that I've used, data analysis, which will include discussion, results, and recommendation. Finally, the conclusion. The study explored the adoption of predictive analytics in pilot training across South Africa, Namibia, and Botswana, with an emphasis in AI-driven technologies to enhance training efficiencies in aviation safety. Predictive analysis can forecast and mitigate risk, for which current studies also show that human error, which accounts for over 70% of aviation incidents. However, in Southern Africa, adoption of these technologies is challenged by a limited AI literacy, social and political implications, technological infrastructure due to the environmental constraints, particularly that we have environments which include remote regions, making it crucial to address these barriers. The study's motivation is the need to improve aviation safety in Southern Africa, where human error still also plays a big role in terms of the accident that actually happened. And so AI knowledge, technological infrastructure, deficits, and regulatory limitations that exist. Apologies, I just need to move the... Okay, I'm fine, thank you, sorry. The study aims to leverage predictive analytics to improve aviation safety by identifying pilot performance issues and operational risk. In terms of literature search, the literature search was conducted using a systematically to ensure cohesive review of existing literature, focusing in Southern Africa specifically with a specific emphasis in South Africa, Namibia, and Botswana. To guarantee the data relevance and accuracy, the material evaluated were restricted to conference papers, peer review journals, government reports published during the past decade. In terms of literature type, the selected literature review included narrative reviews and systematic reviews. The initial database searches were conducted using predefined keywords Boolean operators to identify relevant publications. Major academic databases such as Google Scholar, PubMed, Web of Science were primary source of peer-reviewed journals, articles, conference papers, including official aviation reports. In terms of literature review, the study focused on exploring how predictive analytics can be integrated into pilot training programs in Southern Africa to address and overcome the challenges related to technological infrastructure, regulatory constraints, and limited resources. This interrogation is crucial for improving aviation safety, a cornerstone for fostering economic growth within this region, connecting through safe and reliable air travel. For the purpose of the study, Southern Africa is specifically limited to South Africa, Namibia, and Botswana. In terms of range of literature reviewed, encompasses studies on application of big data analytics in airline, role of AI in aviation, risk preparedness, and specific framework for anomaly detection in flight operation. Exclude literature that does not directly communicate convergence of predictive analytics pilot training, specific regional context were excluded. Study incorporates methodologies for collecting and analyzing digital trace to enhance pilot training programs. Integrating new technologies, a study identified gaps in knowledge relevant in Southern Africa and proposes framework for integrating data-driven approach into pilot training programs in the region. When predictive models show success in solving crime, showcase cross-industry potential of AI-driven risk management strategies as a role of AI and big analysis, which can also seem to be applied in this environment. Studies show that AI technologies could help identify weaknesses in pilot performance and tailor training programs, which is the research study locally made in the University of Johannesburg. Challenges, regulation, and consideration in Southern Africa include studies that emphasize the need for robust technological infrastructure, where regulatory constraints and resource limitation further complicate adoption. The study considered these obstacles and proposed strategies to surpass them, facilitating the seamless integration of technological development in the region's training program. When examining the use of computational digital trace data to ensure ethical collection, regional regulatory and technological factors must be considered to fully leverage the potential of AI aviation. And finally, for future research, should explore diverse data sources and AI-driven methodologies, including digital trace data, to improve the integration of AI-driven approach in Southern African pilot training programs for enhanced efficiency and safety. In terms of the framework used is the Diffusion of Innovation framework, and this is how it looks like in terms of how it's structured. I'll go further in it. Firstly, the reason what justifies the use of this is the Diffusion of Innovation framework strategically addresses adoption challenges specific in the aviation sector. This approach facilitates the nuanced understanding of how these innovations are diffused across the region. Secondly, this theory examines various factors influencing adoption processes, including innovation characteristics, which includes constructs such as relative advantage, compatibility, complexity, triability, and observability, communication channels, social systems, and temporal factors. By adopting this principle, the study objective is to determine factors that either enable or hinders the adoption of predictive analytics. And lastly, this study focuses on the stages of adoption specific to predictive analytics in Southern Africa pilot training. These stages include knowledge, persuasion, decision, implementation, confirmation, which plays a crucial role in the successful adoption. Additionally, understanding these innovations' characteristics informs the diffusion strategy. The pilot training construct, as shown, significantly influences the adoption of predictive analytics technology. These constructs encompass factors unique to training environment, including alignment with regulatory standards, customization to meet specific training needs and compatibility with existing training infrastructure. For instance, predictive analytics must adhere to safety performance, which is very important, performance requirements as well, set by aviation authorities such as the one in SACA, also in terms of the other countries, which is the NAA and so forth, ensuring seamless integration into the training programs. The technology's ability to personalize learning and adapt to individual trainee profile enhances its relative advantage, making it a viable tool for improving training outcomes and safety. This research relies on secondary data collected through established aviation bodies, such as the NTSB and regional authorities. In terms of justifying and evaluating the use of secondary data includes the decision to use secondary data was based on the availability, scope, and reliability of data. Primary data from pilot training records and safety data present significant practical and ethical challenges, which will take a bit more time, and then you end up focusing on getting the data, then actually working on finding the insights and drawing the insight from that. Data used strengthened by its origin, since it's from this regulatory organization, from well-established aviation bodies such as the one indicated here. The limitations identified were mitigated through data transformation, integration of complementary data sources. The platform utilized to integrate both machine learning techniques and traditional statistical method, providing actionable insight. It focused, in terms of the limitation of the data, it focused on incident and accident, but did not provide detailed information on pilot training programs or the adoption of predictive analytics based on the source of the data that Cross went to. There are potential inconsistencies in the reporting standards between different countries, which could induce biases or gaps in the data sets. As a result, certain insights related to real-time pilot training programs or predictive analytics are inferred rather than directly observed. One issue with the data was the lack of granularity in older incident reports, particularly regarding detailed pilot performance metrics and specific predictive analytics application. In terms of data analysis and results, the study will use the digital trace data from the NTSB dataset and Skyberry reports to complete the quantitative analysis. Furthermore, Cadle, a platform for data science, was adopted for data analysis to generate the graphical insights that we'll show. In terms of the findings and observations from the data, the significant number of fatal and serious injuries, specifically in South Africa, suggests a critical requirement for improved risk management and emerging response training. Additionally, the frequent reports of unknown weather conditions indicate a gap in weather data integration, underscoring the importance of incorporating comprehensive weather analysis into training programs. The number of accidents or incident occurred is often during the daytime, as shown in all three countries from the heat map. This may further suggest the environmental aspect of Southern African terrain, which is very unique since in terms of infrastructure as well, that is supported by the data in terms of how the incident and accident actually happen. That suggests a standardized training format might not be adequately preparing pilots to unpredictable or imperfect landing condition. As a result, pilots could underestimate potential turbulence or become overconfident, leading to issues described in the observations. The topic model, which shows observation from applying a non-negative matrix factorization, a machine language technique used to topic model to identify topics that we find on the data sets. These are the top 5 that were observed. By identifying and focusing on this topic, researchers and practitioners can address specific areas of concern, improve practice, and enhance safety measures in aviation. Results. South Africa has, as seen on the previous slide, South Africa has a higher number of aviation incidents than the other two countries, highlighting the need of stronger safety measures and improving training, pilot training. Key areas requiring attention include more robust safety protocols, better risk management, integrating weather analytics into training to reduce the weather conditions or weather-related risk. Recommendation: standardized data reporting across the region is essential to improve incident data accuracy in enhancing predictive analytics for safety improvement. As also the numbers have shown in the two other countries, that they are more or less than as compared to South Africa. Developing a specialized training model tailored to regional operational challenges and improve maintenance protocol are critical to improve aviation safety outcomes. In conclusion, predictive analytics using AI-driven techniques like natural language processing and machine learning can significantly enhance the scene in terms of the observations, pilot training in Southern Africa by addressing operational risk, improving decision-making, and reducing human error. Improving the data platform that was used, the data platform that was used to actually extract data by increasing data granularity, particularly regarding pilot training, predictive analytics would enhance the value of aviation safety research. Collaborating between aviation authorities, training institutions, and regulatory bodies as guided by the Diffusion of Innovation framework is crucial for successful integrating predictive analytics in pilot training. These are some of the references that were used, that were highlighted. Thank you.